Welcome to Summarize Science, where we break down complex research for everyone. Today, we're looking at a breakthrough in 3D scene generation called SceneAssistant. Imagine telling an AI to create a campsite with a tent, a campfire, and a few chairs, and having it appear perfectly in a 3D space. In the past, this was incredibly difficult because AI often struggled with the logic of where objects should actually go. Objects might float in midair or overlap with each other in ways that simply didn't make sense. The researchers behind SceneAssistant have changed the game by giving the AI a set of eyes. Instead of just guessing once, the agent creates a scene and then actually looks at a rendered image of what it built. This is called a visual feedback loop, and it allows the AI to catch and correct its own mistakes. If it sees that a lantern is sitting inside a table rather than on top of it, it can decide to move it in the next step. To do this, the AI is given a library of action APIs, which are like professional tools for 3D editing. These tools allow the AI to create, duplicate, delete, move, rotate, and scale any object it needs. This system uses a vision language model, which acts as the brain that understands both text instructions and visual images. By looking at the scene from different angles, the agent gains a better spatial understanding of the world it is building. It even handles collision detection, receiving warnings if two objects are bumping into each other. This open vocabulary approach means the AI isn't stuck with a predefined list of items it can use. It can handle nuanced and creative requests like a Japanese street corner with a utility pole or a Lego classroom. Another powerful feature is that human users can jump into the process at any time. If the AI is almost there but needs a small adjustment, a person can give a natural language command to guide it. This collaboration makes the final results much more accurate to what the user actually intended. When compared to older methods, SceneAssistant consistently produces higher quality layouts with fewer errors. It avoids the rigid templates that made previous 3D generation look repetitive or unnatural. So, what are the most important points to take away from this research? First, SceneAssistant uses visual feedback to iterate on its work, much like a human artist would. Second, it uses a flexible set of tools that allow it to understand any kind of object or environment. Finally, it supports human-agent collaboration to ensure the final product is exactly right. In the future, this could mean that anyone can create professional 3D environments for games or movies just by talking. We are moving toward a world where the technical barriers to complex 3D design are completely disappearing. This technology could also help robots learn to navigate complex indoor environments more effectively. It marks a significant step in making AI more spatially aware and capable of complex planning. Thanks for watching this overview on Summarize Science.